Okay, so what they're saying here is you have 300 feet, and you have a parabola that comes this way, and you have a height h that travels 300 feet, at time is equal to 4. Okay, so anytime you have something where you're solving for a y, just go ahead and go at y. Y is equal to y0 plus v0 sine theta t plus 1/2 at squared. Okay? In this case, you have v0 sine theta 4, because we know it's 4 seconds for t, is equal to 1/2 g times 16. 4 squared times squared. Okay, so v0 is equal to 19.6 divided by sine theta. For the x side, real quick, x is equal to v0 cosine theta t. Alright, so 300, we know the feet is equal to 19.6 all over sine theta, cosine theta times 4. Okay? And here, tangent theta is our cosine over sine theta. Tangent theta is equal to 0.261, just plug that in your calculator or approximate, and theta is equal to 14 degrees. Okay? Now, it reaches its max height at, you have 4 seconds that it takes to go here. Well, halfway through at 2 seconds, time is equal to 2, you can get your height. Okay, so y, we already know, y is equal to y0 plus v0 sine theta t plus 1/2 at squared. That's g, so y is equal to 0. It starts at 0, 19.6 over sine 14.646 times 2 seconds plus 1/2 g 2 seconds squared. Solve for y is equal to 19.6 feet. Okay, so keys with projectile motion, just look for what you're given, what's going on. You're basically trying to find h, so you want to set up for your y's. Okay, but you'll need your x's too to get your angles. Okay, so that's that one. Moving right along. Moving right along here. Okay, next, list and discuss Newton's laws of motion. Okay, well, you need to know these, because Newton basically founded physics. Alright, so the first law of motion is the law of inertia, which is basically anything at rest stays at rest, anything in motion stays in motion unless it's acted on by outside forces. The second one is your big one. Alright, so your first is inertia. Just remember that. Your second is F equals ma. Okay, so force is equal to mass times acceleration, and acceleration is directly proportional to force and inversely proportional to the mass. The direction of the acceleration is in the direction of the force. Okay, the third one is basically your action-reaction one. So for any action, there's an equal and opposite reaction. That's your third law. Okay, if I push on this, it pushes back on me slightly. Okay. Equally. Okay? Unless my force exceeds it, then it's going to move forward. Okay, next. That's better than the sponge side. Okay. Alright, next. A bullet with a mass of 10 grams and a velocity of 100 meters per second embeds in a wooden block with a mass of 1,000 grams and it's suspended by a rope. How high will the block swing in the vertical direction? Okay. Basically, you got a bullet coming in. It's going to hit a block. And that block's going to swing up. And the bullet's going to be in the block. So you know you got two masses connected. So you need to, with the two masses connected, you need to think inelastic collision. Okay? So for inelastic collision, your m1v1 plus m2 v2, that was resting, so that's going to be 0 is equal to m1 plus m2 and vf. Okay? So here you have 10 grams times 1,000 meters per second is equal to 10 grams times vf. So vf is equal to 9.9 meters per second. Now, how high does it go? Well, the change in kinetic energy is going to be equal to the increase in potential energy. Okay, so your change in kinetic energy here is 1/2, instead of mv squared, it's m, since they're combined now, is m1 plus m2 vf squared, okay, which is equal to m1 plus m2 gh, okay? Well, to solve for h is equal to the vf squared over 2g, which is equal to 5 meters. Okay, no problem. Next, here's another projectile motion one. So what are we going to look for in projectile motion ones? So we're going to find out x and y sides of each one. So in this one, given a rocket sled, all right, with initial velocity equal to v0, okay, find the total distance the sled travels. So we're going to want to know, basically, the main thing we want to focus on is the x side. So we know that x, the distance, is to be x0 plus v0 cosine theta t. Okay, we also know that y is equal to y0 plus v0 sine theta t plus 1/2 at squared. In this case, it's going to be g. So negative direction there, so it's equal to y0 plus v0 sine theta t minus 1/2 gt squared. Okay, cool. So here we have v0 sine theta t is equal to 1/2 gt squared. So t, we've done this before, is equal to v0 sine theta over g. So x is equal to 2, plug in for t, okay, in there, that's going to be 0. It's equal to 2v0 squared over g sine theta cosine theta. And you can finish there, you can use your handy dandy identity, 2 sine theta cosine theta is equal to sine 2 theta, so we'll just say that is equal to v0 squared over g sine 2 theta. Okay? Simple enough. Hopefully this is, as we go through these here, this is helping you out and getting you a little more exposed to it. I mean, obviously you can go through and practice these. I'd recommend practicing each one of these problems several times. You can see that I've got all these on flashcards here. I'd recommend go ahead and write out the flashcards and just run through the flashcards a little bit every day. Just as you're getting ready physically to go to training, you need to get ready mentally too for your interviews. It's an easy one. Find the time it takes to hit the ground. You've got a ball that's going off. It's got an x velocity v0. It's got a height of h. So, I mean, it doesn't get any easier than this. Y is equal to y0 plus v0 yt minus 1/2 gt squared. Okay, so h, this is going to be h, is equal to 1/2 gt squared. Okay, so time is equal to the square root of 2h over g. It's that's a basic problem. So, that's your time. Good. If I move too fast, I mean basically, like when you drop something, it's 1/2 gt squared. So the distance, y is equal to 1/2 gt squared. Solve for t. Okay, so it's 2y over g square root. That's h, right? Sorry, that's h. I mean, that's the only formula you really need to know. I was just expanding it in the beginning. All right.